Thank you, sir. Firstly, I am amazed at the level of energy Dr. Anil Razdan and also Anil Garg, they represent at this age. I am sure for all of you youngsters who are assembled here, these people are marvelous role models. I have been seeing Mr. Razdan in various platforms, organizing various events. I am amazed. Thank you, sir. You are at least for me, you are a role model in that. So quickly, what I thought is, we have been talking of this digitalization, and then I thought I will briefly explain a little bit about what are these technologies and how they are enabled and how they are enabling the energy sector. This is what I will briefly touch upon. Thanks, Dr. Lakshma Reddy. He has already covered some of the issues. We both visited the data processing center for Oil India in Noida, which is run by some Russian group handling the, I think, Andaman Nicobar or some data of the basin. And there I realized what is the real challenge. I was hoping to see Ms. Sushma Rawat today because I visited Jorat Center of ONGC, sir, where they are capturing the data and doing some processing. I had spoken to the people working on this digitalization. I had seen some of the real challenges they are facing and why this is needed. I will be touching upon these briefly. So basically, these there is always a change in technology, and one change in the technology shoots up something, and then suddenly a lot of things spring up. Today, for example, the speed of the computer was a big issue. When I was a student in 80s, or Lakshma Reddy was a student in late 80s or something like that, computational power was a big problem. Those days, whatever power I had in my so-called big computer, today it's available, much higher capacity is available in our mobile phones, the phones you guys use. So these kind of things happen, and this was enabled by small development of the materials and the chip design, etc. So suddenly everything became
Dr.
so easy.
Shamasundar, I think I'm just tempted to, just because the young people are sitting here,
Yeah.
you cannot imagine. You see, in the late 60s, when I was going through the university, a computer which was much less efficient than what you have in your pocket was in a building maybe twice the size of this.
Yeah,
So
the people
that is the transformation that you people
exactly
are witnessing today.
Exactly. So, so a lot of things have happened, and there are some 5-6 things that are happening today, which is accelerating and making this transformation, digital transformation, a much more easier and much more comprehensive and much more easy to digest technology today. So these are some of the technologies. The top ones are IIoT, that is industrial IoT, edge computing, cloud computing, AI, ML, and DL, data analytics, that's used for creating digital twins, AR and VR, which is artificial augmented reality and virtual reality, etc. These are some of the technologies. I will mention a little about this. But then there are independent parallel developments in each of these, which are together helping the oil and gas or any other energy sector. Next slide, please. So this is what we mean. So earlier, when I was a student, digitalization meant converting a drawing into a digital form, a hard copy of the drawing in a plain sheet to a digital form, which can be 2D AutoCAD drawing or something like that. That itself was called digitalization. And in the business terms, maybe you put your data on the Excel sheet or something, that itself was called digitalization. And later it moved to become what we show on the left-hand side, the plant model, a 3D plant model, which is again called as a digitalization in a few years back. But today, as I said, there is a lot of other issues that have come in. So this, whatever in the left-hand side bottom image, what we see today is called generally digital plant engineering. Thank you. Yeah. So next is IIoT, which is basically, earlier you have all heard of sensors. You all have used sensors possibly in your tests. These sensors take the data of whatever, it could be pressure, speed, flow, blah, 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 and then they tap the data. And this was just called instrumentation. That was not called a digital technology. This was IIoT. So what these are, number one, earlier it was purely analog, and today it has become digital. What it means is there is a lot of computing power that these devices itself has. Today, for example, you can have a pressure sensor, and assume your equipment has to go below some X pressure, 100 bar pressure or whatever, some X pressure. And the moment it goes, these devices, the instruments, can be tuned to raise an alarm, red alert. So that way it becomes intelligent. So they are not just sensing, they are doing some intelligent function. That is when they become IIoT. And now these are internet connected. There are multiple systems in a power plant or in a oil and gas refinery or whatever, and these guys can talk. And this is where the IIoT became as a technology. And then next level of technical advancement was coming in these, what they call as edge devices. These edge devices, they have a small computing capacity. For example, there is a turbine, there is a temperature sensor, and at the end of that turbine itself, you have a small computing, which is called edge device. And this collects the data, again does some processing. So it is not just transmitting, it is just doing some intelligent processing there itself. And then these are called edge devices. I am putting in very simple terms. It's not as simple as that, but I am explaining in very simple terms. So these are edge devices. And the function of these edge devices is to tap the data and then send the data to either a server, which could be a hard server, or it could be a cloud-based server. So these are transmitting devices, but they are not just doing transmission again. They are taking the data, doing little bit of processing, and then further passing on. So this is the edge computing technology. There is a lot of work on this. Both IIoT and edge computing are intertwined, and a lot of work is done. There are several startups in the country who are doing wonderful job. And this data then is taken to the cloud. Dr. Reddy was mentioning about having a data which can be used by anybody. You put the data of, say, Indian seismology data on the cloud, and people in South Africa or Africa or Germany, wherever they want, they can download the data and use and see how this data looks like. So that is cloud computing. These are all different technologies, but parallel developments have happened. So up to this is one block. Then you have a lot of data. Just to give if you want to imagine some number, there is a flight, for example, there is a army or aircraft or Indian Airlines, they are operating aircraft. Every minute or every second, if engine runs, a flight engine runs, a jet engine runs, there are about 3 million data points collected. You assume the flight from Bangalore to Delhi is about 2.5 hours. You imagine the volume of data that is getting generated just in one simple flight engine. This is the volume of data that is getting generated. And then this data needs to be analyzed. If it is simple, some 200-line Excel sheet, maybe we can do some pivot or some simple things people can do, students can do. But such large data, the handling itself has a problem. Data structure itself has a problem. This is where then the question came, how do we handle this huge data? And that is when this big data analytics or data mining, etc., they came into picture. And this has some algorithms, some technologies, how to handle the data and how to process the data and get the information. This is the crux. And that is handled by this data analytics part. The next thing that came is, we have the data. What do we do with this data? Unless data is used for inferring something, it could be an engineering judgment, it could be a business judgment, whatever, it could be even in medical practice, it could be a judgment to whether to repair or not repair, or take surgery or not do surgery. Or in a plant, whether to repair a asset or reuse the asset or just throw it away. So these are all judgments, and these judgments are done based on this so-called analytics. And these analytics are today at the core of what is called as a digital twin. Okay. So I just want to make one small statement here. People mistake that these artificial intelligence models are neural network models with a physical model. What I am showing here on the left-hand side bottom picture is a physical model. You imagine, this whole building in a drawing 3D CAD model kind of thing, and that will be a physical model. And that is what I am showing on the right-hand side top is a digital twin, which is again a physical model, a physical mimic. But then these things take a lot of time to analyze, to do processing, etc. So in data management, in data analytics, what we do is we do not consider the entire model. We consider the representative data points and we create low fidelity models. Next slide, please. Yeah. So, so what's a model? Can somebody say quickly, any of the students, what is a model? What is a model? Yep. Yeah, it represents something. The gods that we see in our temples are models of whatever, somebody said, okay, this is the form of a god. So this is a model is representing something. There is a reality and you are representing by something else. That is a model. And, sorry? Method, yeah. So a model represents something by something else. And what is simulation? We are trying to mimic a process. We are trying to replicate a process somehow, differently. And next slide, please. So a model can be a mathematical model or a numerical model or a computational model or a digital model. All these are same. At the core of this is what we call as a governing equation. A mathematical model, a equation. These are being basically solved. This is the modeling. And when we say simulation, in reality what we are doing is, on the computer, we are solving those mathematical equations which are called as governing equations. And then we are trying to solve that problem. Basically, these equations are all partial differential equations of higher order, which is second order or third order, etc. And we are solving by using various methods, numerical, computer simulation, digital simulation, etc. So that is when we get the real information. Next slide, please. I just thought I will introduce these basic concepts so things are clear to us. So what is machine learning model? This machine learning, deep learning, have become buzzwords today, but then let's understand what does it mean. When we say machine learning, Mr. Razdan mentioned about this, it's like human brain. My wife asks me something, I will not do it, her reaction will be different. I ask for something, I will do it, the way she ends, her reaction will be different. So these two incidents, my mind grabs and stores some knowledge. Okay, Bagar, don't do this mistake. If you want to get food in the night, you behave properly. This is an implicit message. That goes, and that message will be stored as a knowledge in the brain. I am going in the road, if I go in this direction, in the evening, I will get traffic jam. So I will go in this road, it doesn't. So there is an instant. So there are 2-3 instants like that. And then the brain learns how to operate. And next time such a situation comes, brain automatically drives you to take a decision what to do, what not to do. And exactly the same way, the machine has to be trained. And the machine has to be made to learn. So this is what is machine learning. It is very simple. So in simple terms, all the experience that is captured in the form of a data. Computer doesn't understand anything except data. Whether it can be ML or DL or whatever, all the models, they depend only on the number, that is on the data. As long as the experience is gathered in the form of a digital signature, whether the failure of equipment or failure of your geophysical data, as long as it is in the form of a digital repository, digital data, then computer can be made to understand it and computer can be made to learn from that. That is what is the machine learning. Next, please. So this is very important. This is there are offline simulation models and online simulation models. Offline is like finite element analysis or computational fluid dynamics, etc., which take long time to do. If you want to do the full-blown simulation of a compressor, it may take several weeks or even months to simulate. Whereas you cannot predict the failure, or you cannot get the model of this thing running for weeks together to give you any information in the real life. It can be used for getting knowledge, but then really you have to have quick insights. For that, online models are used, which are basically low fidelity models. They can be with feedback or without feedback, etc. And there can be hybrid models. Next, please. So these are predictive models and prescriptive models. Thank you. So in this, for example, this is I think this is of a compressor, or I don't know, but there is a vibration data. What you are seeing in the red is the actual data. And what you have shown is you have measured this data, and you have trained the computer to use this data to predict the behavior. You can see these are, the red and blue lines are going well. Once you have this computer model which is trained, then you can use this to predict in the future and then develop the prescriptive models. What you are seeing in the brown or saffron or whatever, that is the projected data. This is based to project the future events. So this is the way the digitalization helps. Next. I think I will stop at this and I will just take 2 minutes. Basically, benefit of digitalization can help in many forums, as Dr. Lakshma Reddy said. But in exploration sector, there are 2 key challenges which ONGC or Oil India or anybody exploring this are facing. Basically, they are investing money to explore. Exploration is a very, I'm glad to see Banial Saab is here. I was told he's behind the formation of this RGIPT with which I am associated. I was also drafted to RGIPT, sir, to create a vision for Bangalore Center, and now I am the president, and then create a DPR for that, and that's how I got associated with RGIPT. But now I am the president. I am very glad to see you here. The biggest challenge ONGC or any such exploration company has is they have a very huge, expensive program. This oil exploration is a very expensive business and very risky business. The percentage of success could be as low as 14–15% or less than 20%. So how do we assess if I am doing the rigging seismology data and I have to decide where to rig, then there is a lot of things that are happening. This is where digitalization can help today. The first problem I have seen is when the seismology survey is conducted, for the benefit of the students and juniors, seismology survey is you have a huge data of several square kilometers where earphones are applied, and then there is a source of vibration like a blast that is given, and then the data is collected. And this data has to be analyzed. This generates tons of data. You may be thinking 5 MB data is big, or 30 MB data is big, or 1 GB data is big. But then these are in the order of terabytes and petabytes. And this is huge. That is the problem which DGH is having. And how to put it in code, I don't think that issue is still resolved DGH may. So how to transfer the data or where to put. But then there is a huge data. And that data has to be filtered. This is the first problem. When you are vibrating, for example, you are assuming you are some 10 by 10 kilometers you are doing this seismic survey, and there is a bus going somewhere else, that will affect your seismic data, which is basically vibration, or there is some other train or something going on. All this creates noise. How do we clear this? How do we filter this noise and get pure signal data of the acoustic emission? This itself is one of the biggest challenge. From my experience of visiting Jorhat, I could see that this itself is taking about 9 to 12 weeks or even more for this. And that is, I'm talking just of 2022. I'm not talking of very olden days. With advent of these kind of technologies of big data analytics and filtering noise, etc., this can be just reduced just like this to issue of few hours at the most or few days. So that way the time is saved, number one. Number two, this becomes very repetitive. Now there is an experienced engineer or a technician. If he leaves, if he goes on leave, okay, this will be further delayed. So this kind of a filtering of noise is one of the area where this can be really helpful. The second is in the interpretation of the geophysical data, which also both these were touched by Dr. Reddy. And the interpretation is much more difficult than the data filtering. And this is again taking anywhere from 2 months, 3 months to even 9 months. I was told when I visited, they take even 9 months or more for the interpretation. So this way, if we use this artificial intelligence and all the digitalization techniques, the data processing, once the seismology survey is conducted, that can be extraordinarily reduced. What is now taking order of almost 1 year can be possibly reduced to a month or month and a half. This is the kind of benefit that this technology provides. Then people like ONGC can take a decision just like that. Okay, will I go here? Will I try 10 sites or will I try 1 site? So this kind of judgment can be taken. So it's a very powerful technology. In India still it is happening. But then there is a lot of opportunity for you. If I assume some of these are students, there is a lot of opportunity for the new students to generate companies, to generate technologies and become entrepreneurs. I have a couple of people who are already working, they are in my loop, but this is the way the country is heading towards. Now this is a golden opportunity for whoever is interested in becoming entrepreneur, not only in the energy sector, in any other sector, to use this technology to become entrepreneurs and develop technologies. With this, I conclude. Thank you very much.